Frankfurt Airport, Germany's largest airport, is building a new terminal covering 176,000 square meters and at a cost of 4 billion euros.
This is both Europe's largest construction site and biggest infrastructure project.
Terminal 3 is projected to hold up to 20 million passengers arriving and departing every year. To accommodate these numbers, a huge main terminal building and 3 long piers are being built.
There's a lot to do. Now we're at the height of the shell construction.
All just in time.
That's the schedule. The clock is ticking.
With the 69-meter high tower in the middle and the fully automatic Skyline train across the whole site, whether the crews are laying down new train paths or moving between stories, many of the construction areas are located at dizzying heights.
Every lift assembly has its challenges and risks.
Falling from 3 meters is bad enough, but when you work at heights like these, it just slows down the whole process.
Construction as far as the eye can see. It's big picture thinking in more ways than one.
Why does it work?
Good question, because it has to.
Late at night, outside Terminal 2. Wolfgang Holzhausen is excited for the next milestone. As project manager, he's responsible for coordinating all the different building operations for the Skyline train, which will soon lead to Terminal 3 right here, parallel to the existing route. For the 2 new tracks to be built, the existing frame must be extended.
We've come a long way with the track construction. We're building 47 individual pillars, and we're preparing or building 17 frames, which will hold the girders for the tracks. And the work we're doing tonight is unusual in that we are lifting an extremely heavy prefab part, which requires that we close some of the roads around Terminal 2.
One of the closed-off roadways is the Hugo Eckener Ring, 1 floor beneath the Skyline framework. Here, workers are laying down bed plates for a large tower crane. A short time later, the crane moves into position so that the special prefab part can be lifted into place. The offset elevation is the biggest challenge here. Since the crane operator can't see the installation site, signalers have to give precise commands over radio. Jürgen Theiss monitors the work from above. As construction manager, he's responsible not only for preparatory steps, but also for the entire lift itself.
This is just one piece of the larger puzzle. We're still doing preparatory work. The truck crane is still being loaded up, so to speak, meaning all the ballast weights and counterweights are being raised onto the counterjib. Then we switch the number of the hoisting ropes so that the crane has enough power. And then we're already good to go.
140 metric tons of counterweight are assembled and slotted onto the crane. This amount of mass is necessary to raise the frame part safely. At midnight, the prefab part arrives straight from a plant in the town of Neumarkt. At 12 meters long, it weighs 70 metric tons.
It's a very heavy part which needs to be lifted and then placed into the reinforcement. We're anxious that it all goes according to schedule so that we don't disrupt the nighttime traffic here, even if it's not busy.
The last airport buses are able to pass under the installation zone. Then the road is closed. Shortly before the lift, the team double-checks the load's every last hook and eyelet. The colleagues up above are getting ready too. Scaffold towers have been erected along with casing and reinforcement.
Jede Hubmontage hat seine
Every lift assembly has its challenges and risks. Here we have to place the prefab part onto the scaffolding, which has to be absolutely stable.
Das Traggerüst, das muss absolut stimmig sein, ja? Das muss
It also needs to be properly planned and constructed, since the prefab part has to sit on the scaffold with no possible rearrangement.
keine Umlagerung stattfinden.
The giant is secured. Huge iron bolts fasten the hoist ropes to the carrier. After final adjustments, it starts moving, slowly and cautiously. The crane operator has an easy job up to the bridge railing. And then, what lies behind? Here, the signaler's commands must be right on the mark, with help from their colleagues on the slip lines. It hasn't even been 20 minutes, and the team has been able to move the prefab part right in front of its destination. But something's wrong. It won't fit. Now they must remeasure, reread, and even re-weld. The airport buses are stuck for now. Side by side, construction is taking place in many areas, and they're changing constantly. Bulldozing, rolling, and tinkering work is being done all over Terminal 3. A colorful hustle and bustle of men and machines everywhere you look, setting down cement and steel. There's one man surveying the whole operation, General Project Manager Christian Behrendt. It's his job to stay on track and make sure that all problems find quick solutions.
It might sound boring, but in the final construction stage, we'll have between 3,000 and 4,000 people working here on site, and between 200 and 300 truck deliveries every day, which will have to be brought to the site and distributed accordingly.
When passengers arrive at the new Skyline station, for example, they will enter the heart of Terminal 3. The main terminal building, made up of 3 components. Building 600, the check-in hall. Building 601, the security check area. And Building 602, the futuristic commercial area, from where passengers will proceed to the 3 new piers. Boarding gates G, H, and J, where especially long planes are able to park. In the middle of them will later stand, at a height of 69 meters, the eye-catching apron control tower.
After completion, Terminal 3 will process 20 million passengers per year. As such, the terminal alone will be bigger than Stuttgart, Köln, Bonn, and Hamburg airports individually. We're on a 150,000 square meter site with a gross floor area of 409,000 square meters.
There's a long way to go before airplanes can take off and land here, but some progress has already been made. Flashback to October 2015, when the first works commenced on the mega construction site at the southern end of Frankfurt Airport, taking the place of a former US military base. After 15 years of planning and approval procedures, the bulldozers can now break ground. With a bucket volume of 2 cubic meters, they turn the construction site into a desertscape with skyline views for 6 months. Every day, up to 5,500 cubic meters of earth is moved, the equivalent of around 300 truckloads. The workers excavate a 5.5 meter deep pit, reaching just above the water table. With a volume of nearly 70,000 cubic meters, this pit is big enough for the future terminal's main hall, covering the same area as 9 soccer fields. The special heavy construction team keeps excavating up to 14 meters deep in order to fit all of the technical equipment into the main hall's basement. In order to seal off the plots and provide stability, long sheet piles are erected to close off the area. More than 7,000 metric tons of steel are used here alone. Professional divers help to lay concrete over the basin floor for the foundation before the groundwater is pumped out, treated, and carried off elsewhere and put back into the ground. By mid-2020, some 145,000 cubic meters of concrete and 20,000 tons of reinforced steel later, the pit has been drained and the first layer installed. Since then, Terminal 3 has grown in height and the main hall is beginning to take shape, much to Christian Behren's delight, even if his rounds sometimes get interrupted all of a sudden.
Although you think of a construction site as two-dimensional, you can still run into nooks and crannies and dead ends. And just like a labyrinth, you have to look for the next way to continue towards your goal.
The huge size of Terminal 3 poses unique challenges, which sometimes require round-the-clock work.
You have your base construction, which you have to keep as stable as possible. By avoiding disruptions to the base development, you can let the tower cranes do their job. That's why for particularly large components, you end up using the night shifts more often in order to cause less disruption from large shipments during the day.
Back to the 70-ton girder for the new Skyline train. It's now 4 a.m. outside Terminal 2. The night is nearly over, and the team is still trying to thread the huge block into its place. But the girder's brackets don't seem to match those of the scaffold tower. Down below, more airport buses are gathering, since they can't pass below the installation site during the lift operation. It's a bottleneck.
It's an annoying situation for all concerned. There are people who are probably trying to get home after work. The bus drivers have the same problem. They can't get back to their scheduled routes. So of course we're trying to finish the job as soon as possible. There's maybe a bit of pressure, but with these kinds of jobs the priority is diligence and especially safety.
The team can't simply remove the blockages in this tangle of steel. Each change could cause instability. So the workers must deal with the brackets on both sides very precisely. Every step must be planned in advance and checked afterwards. Small adjustments are helping. They're making progress, bit by bit. Eventually, the heavy component seems to be in place. A few more measurements, and it's done. Construction manager Jürgen Theis can finish up and let his team pack up for the night.
The installation caused some difficulty with the placement of the concrete set brackets into the scaffold's reinforcement. The inaccuracies with the dimensions were tricky for the team, because it came down to a matter of centimeters or even millimeters. In the end, we got it done. It was hard work, especially in the cold weather, but I'm happy we figured it out.
Just a few hours later, the airport buses pass under the newly installed girder. Their passengers are most blissfully unaware of the amount of work done overnight. In a few days' time, the next girder, smaller this time, will arrive. After that, the track closure in this section will be complete. A total of 5.6 kilometers worth of Skyline track is being built to enable an 8-minute journey between Terminal 3 and the train station. The starting point is the new station at Terminal 1. EU and non-EU citizens are transported in separate cars. At Terminal 2, passengers get on, off, or change trains to connecting flights. Here, 2 new tracks will be added to the existing Skyline station, where visitors can then switch between the old and the new trains. The fully automatic, driverless Skyline trains run to Terminal 3 every 2 minutes at a speed of up to 80 kilometers per hour. The station in the new terminal is 150 meters long and 30 meters wide, with 2 platforms to enable trains to arrive and depart simultaneously, with EU and non-EU passengers. This automated people mover, APM for short, runs close to the A5 freeway. The space between the A5 and the existing apron will be used as much as possible. On the left, there will be a public road adjacent to a 2-lane track for the APM, with an industrial road to the right, and finally, the apron at the far right end. Fences will separate all of these into individual security zones. That's how the north and south of the airport will be linked in the future.
The APM route has been determined by the location of the existing Terminal 2 and the new Terminal 3 in the south, with the apron in between. That means we have to go around the side, essentially. It'll be elevated in the north because the Terminal 2 station that we're connecting to is higher up. However, towards the south, we drop again to ground level.
Building at ground level is both easier and cheaper, but it's only possible for 2.1 of the route's 5.6 kilometers. The remaining 3.5 kilometers run over more costly pillars and nearly 200 track girders at heights of up to 13 meters. The girders are raised individually and are diverse in form, length, and weight. Ramps are being constructed between the elevated and lower areas. Wolfgang Holzhausen has his eye on the north ramp in particular, due to a curve.
We've placed the wing walls for this ramp using prefab parts and started to build up layer by layer. Behind me, you can see where corresponding cross beams are being embedded in concrete. Above a certain height, these wing walls must be connected again. And once these cross beams have been installed, we can refill the ramp and finally place the road on top.
The focus is still on the elevated area, where, following the lift of the track girders, several complex jobs need to take place. But before the installations can get going with the energy supply, Wolfgang Holzhausen must check over the raised site.
Here in the middle, where I'm standing now, will be the emergency walkway, level with the vehicle floor. Below, we'll lay down some cables so we can use it for that. This will still be added here in the middle. Of course, there will be a guardrail at the end where the construction guardrail is now. And here we have one of the tracks, with 2 driveways for both the rubber tires. We're using a rubber tire system on a concrete track. The track is slightly sloped inward here so that the water can run off into these gutters, which connect to the bridge's drainage system underneath. So we take in all the water so that it doesn't simply run down uncontrolled. Then in the middle here, we have the guide rail, which is still being installed and which will steer the vehicle. The vehicle will have guide wheels running alongside this rail. What we can also see here is where the heating cables for the roadway come in. This area will be heated to enable full workability in winter.
On the elevated site between Terminals 2 and 3, the workers are constructing a large garage into which the vehicles will be led. On the left will be a siding to work directly on the tracks for the repair and maintenance vehicle. On the right of the building is a 300-meter-long test platform.
That will be used for tests, such as brake tests, and for storage at night, when some vehicles aren't in use. Next to it will be 2 tracks. You can kind of make out the shell of the entrance doors already as the foundation work is finished. That's where the tracks will go, where maintenance work will be done inside the building. To the left and slightly to the back is the cleaning facility, which will be fully automatic. And behind that is the main building with the control center, with rooms for all crews, as well as rooms for things like recreation, storage, and so on.
The size of the garage building enables multiple vehicles to be repaired at the same time. It will also be attached to a large storeroom for replacement parts. since the Skyline train is a unique system that will be the only one of its kind operating in Germany, meaning there must be plenty of parts in stock.
We have very, very high availability requirements, contractually set at 99.65%. This means we must have very low failure rates, because if one vehicle or the whole route fails, then there's a huge impact on the whole functioning of the airport, if north and south are no longer connected. This kind of system requires a lot of foresight and preventive work. And obviously, I can't just take the vehicles right off the track. It all happens in here, centrally, often at nighttime too, because I want to have most of the vehicles in use during the day.
Of course, passengers will also reach the main terminal building by car, taxi, or bus. After going through security, they funnel into 3 piers. Pier J on the left is designed for non-EU passengers. At 600 meters, it's the longest pier, with 14 docking positions alone. Also, on completion, Pier J will be 1 story higher than the adjacent Pier H. The team has just arrived at the 2nd level, called E02. Maximilian Kellermann is responsible for all phases of construction here.
How long do you still need, guys? Half an hour?
Yeah, that'll work.
Good.
These beige-colored Y-supports add a touch of style. 86 of them in total will line both sides of the pier. Each one is 10.8 meters tall, but will be erected at a 7-degree angle, resulting in a height of exactly 10 meters. The installation of a Class 3 exposed concrete component poses some distinctive technical challenges for the team.
The Y-supports carry the cantilevered ceiling of level EO2, meaning they basically support the load from the gate area down to the ground or foundations. The idea is to have 2 load points at the top and 1 base point at the bottom, because otherwise there would be a jungle of supports in front of the building, which you obviously don't want. That's where the tree-like shape of the Y-support comes from.
The Y-supports are constructed at the Precast plant, rather than here on site, which does away with a lot of potential issues. The plant is always dry and well lit, and the formwork can be used multiple times. Each support weighs 22.5 tons and contains 8 cubic meters of concrete and 3 tons of steel. This concrete is known as C5060 and is the sturdiest type being used on the Terminal 3 site. Each finished part is brought in at night since the supports are above maximum width, so they can only be transported as heavy cargo. Once they arrive on site, the Y-supports are delivered as quickly as possible to their installation sites on either side of the pier axis. 2 mobile cranes do the unloading. One of them fixes the support itself, holding it in its correct position. The other sets up the so-called push-pull props, which prop up the frame. These are also so heavy that they cannot be installed by hand. The workers must make sure that the installation goes exactly to measure and that the Y-shaped supports are set at an angle of exactly 7 degrees.
Of course, it's hard to check because there isn't a horizontal or vertical surface that I can compare it to. That's why the boys use surveying technology like theodolites and leave gaps which allow them to basically also check these angular surfaces against a spirit level.
At the same time, Pier J keeps rising so that the first ceiling elements are almost ready to install. The assembly team at Pier G is clearly further along as the shell construction is complete. Here, it already feels like an airport. Even the baggage conveyor is already set up. This is because the 59,000 square meter pier was supposed to open before the other 2 and be functionally independent to relieve the pressure on terminals 1 and 2. But the coronavirus pandemic caused a massive drop in passenger numbers, making this no longer necessary. Still, if there's sufficient demand, project manager Ilma Celio expects Pier G to be able to start operations before the rest of Terminal 3 opens.
The challenge with Pier G is the shorter construction time, which means that a huge amount of work needs to be carried out in parallel. That means we lay the screed at the same time as we're installing the cooling system and sealing the roof on the other side. Everything needs to be coordinated so we can stick to this shorter schedule.
The architectural highlight is in the roof structure, where 3 large round skylights attract attention. The 400-meter-long pier requires 20,000 meters of heating and cooling pipes, 9,500 meters of ventilation ducts, and a total of 160,000 cubic meters of floor screed.
Here we see a relatively fresh layer of screed in our two-tone concept. The lighter part reaches from the shopping area up to the gate area, as a kind of walkway for the passengers to move to their gates. The floor covering at the gates is anthracite, which lets the passenger know that they are leaving the light-colored walkway for the gate area.
A look at the third Pier H. Although it's just as long as Pier G, the construction work is much less advanced here. The workers use a flexible crawler track crane to lift the massive steel parts onto the roof. Project manager Dirk Strunk is overseeing the installation of 2 truss girders, which, together with bottom and top flanges, form 50-ton load-bearing elements. It's a simple screw job with no welding seams.
The steel parts are going to make up the technical floor, which will be detached from the main structure and kind of float above the building. It will be used for all the technical services, particularly the ventilation.
A total of 14 steel parts must be installed over the coming weeks, lending the pier a distinctive look. The roof of the main terminal building will require a particularly elaborate installation. Upon completion, the massive black structure hanging over the arrivals hall must not only look sleek, but also keep passengers dry. For now, though, the building shell is still pretty wet. But General Project Manager Christian Bierend isn't too concerned with a few puddles, because here are some new blue scaffolds which mark the start of one of Terminal 3's most distinctive structural features.
So here you can see the first elements of the so-called auxiliary assembly structure. Later, this will extend from west to east. The assembly platform will actually be placed on top of the steel structure. And that's where the first segment of the roof will be assembled in a position to push it over to the east.
Assembling the roof vertically and then sliding it into its final position is the most unusual solution. But according to the planning team, it's also the most efficient. Everywhere and always, just in time, no matter what size you're dealing with.
To give you a sense of the dimension, the first segment of the steel roof will be around the size of a soccer field once it's installed. That means the entire depth of Building 600, the check-in hall, the size of a soccer field, will be pushed back in one piece.
Down in front of the main terminal building, the next blue elements of the auxiliary assembly structure are ready. Many more will follow before the workers face probably their toughest task: moving a 10,000-ton roof. But before that, other milestones are to be reached at Terminal 3.
Obviously, we're not completely finished with the shell construction yet. The apron tower is still a challenge for us, as we're using a different technology here. We will use a climbing formwork so that we can build upwards.
On completion, the apron control tower should be 69 meters tall. Here, the air traffic controllers will monitor all ground traffic at Terminal 3 and decide who can move across the apron and when. This climbing formwork requires a crane to lift up pre-assembled formwork parts for the outer wall, story by story. Every 2 to 3 weeks, a new reinforced concrete floor is poured.
The climbing formwork consists of 12 working levels, which form a circle around the floor plan of the tower. They are fitted with wind protection devices which keep them firmly connected to the tower during strong winds, for example. This is also for safety reasons, so nothing can fall down. Before we do anything, these wind locks have to be loosened and the formwork pulled out around 20 centimeters from the outer wall so that the individual elements can then be moved up with the crane.
Up on the tower, foreman Alexander Becker and his team make preparations before they can raise the outer wall.
We measure the wall before it's reinforced. Up where the screw holes are on top, an assembly part will be put in where this spool can be screwed in afterwards. Then the working level is attached on a steel girder with a nut which goes into the spool. And the whole formwork is then screwed on from that level.
Small parts with a big impact. Each formwork part weighs between 4.5 and 5 tons. 13 levels are complete, a total of 53 meters in the air. Heights like these are not to be taken lightly.
Hey! Railing, railing.
Falling from 3 meters is bad enough, but when you work at heights like these, it just slows down the whole process. It makes you more cautious, or at least it should. That's also the job of the supervisors and foremen, to make sure that everyone acts more carefully when working at a height of 50 meters, and more importantly, to take technical precautions like fixed railings as fall protection.
The last element is lifted up, mounted and anchored with a wind safety device without a hitch. Soon, the tower control center will be built here. All 86 Y supports have now been installed at Pier J, and the level 3 ceiling already juts out above them. Maximilian Kellermann's team is now in the process of attaching narrow edge supports on the outer end of the pier's facade. Pier J will receive 366 of these parts, which, like the Y supports, are prefabs, each of them weighing around 2 tons.
Pier J is defined by this specific mixture of on-site concrete and shell construction with reinforcement and formwork, as well as more than 4,000 prefab parts. They're produced and cast at plants on other sites and then delivered to this site by trucks to be joined with the shell construction.
A crane lifts the edge supports one by one onto level E03, where 2 workers receive them and put them into temporary storage. Then each support is transported to its installation site upright. There, the workers can set them up and fasten them. This interface between prefab parts and on-site concrete must match exactly. If the support is stable and straight, after a final check, it can be wrapped up in foil to protect it from wind, weather, and building dust. Then, it's on to the next one.
There's a lot to do. Now we're at the height of the shell construction. We're mainly focused on the load-bearing parts, the supporting structure. We've laid down between 2,800 and 3,000 parts out of 4,000 in total.
The team laying these parts and carrying out the parallel shell construction is 170 men strong. Between 2 and 4 mobile cranes are being used, as well as 8 rotating tower cranes up above. The workers lay down up to 30 precast parts per day. Apart from the edge supports, there are other important precast elements which make up Pier J. Down below, a truck is delivering a shipment of crossbeams, which are Pier J's most used load-bearing parts, at a total of 1,200. Later on, they will support the roof of E03. One of the workers is taking photos and checking each element before installation. There are also several trough plates weighing 25 tons, with 4 tons of reinforced steel. These also form part of the ceiling construction.
We have to lay almost 100 trough slabs, which are then laid piece by piece along the pier from one area to the next and are an extremely important part of the E03 ceiling. One of the key characteristics is that they form this tub-like cross-section. You can see here quite nicely, this is where more prefab parts will be laid on later on. These are essentially support slots for the crossbeams.
In die im Prinzip dann die Querträger aufgelegt werden.
Up on level E03, some have already been installed.
Behind us, we can see the finished ensemble of prefab parts. First, the trough plates with the circular cutouts, the cross beams, which in turn rest on the trough plates, and the outer beams, then the supports on the outside, and in the middle here, the on-site concrete double pillar support. So everything apart from this double pillar support is pre-made, while the pillar itself is beige concrete, which was formed, reinforced and cast here on site.
The trough slabs hold the crossbeams in the middle. On the pier facade, the so-called outer beams will do the same job. These are the last important precast elements on the site and will arrive next week on the western side.
Here, one of our outer beams is being prepared for installation. It goes as follows. The outer beams form the side edge of the E03 roof. Instead of simply taking the precast part and lifting it up, we raise it off the truck and then, which you can see very nicely up here, we install the guardrail, and only then is the whole part lifted.
The outer beams, which have an L-shaped cross-section, are unloaded onto prepared square timber beams before the guardrail is installed. The lift follows straight after. Even at 15 tons, the beams pose no problem for the mobile crane. On the 532nd axis, the last beam is prepared for attachment. Then, the finished part can go up. Here, the team must place it into the edge supports reinforcements, measure once more, and then fasten it at the end. The workers on the cherry pickers complete the job. The installation took exactly 30 minutes. Down below, Maximilian Kellermann is already checking the next truck delivery. A constant loading and unloading.
Basically, we deliver and install our prefab parts just in time. In other words, we aim to install the parts on the same day as they arrive on site. Depending on external factors, it doesn't always work like that. But ideally, the whole operation is done within 24 hours or 36 hours at the most.
Pier J is heading steadily towards completion, part by part. But Pier J is hardly the only construction zone full of gear. Construction logistics is a site-wide issue for Sebastian Wolber, project manager at the tower. With such a mammoth project, it's normal for materials to be relocated and temporarily stored before installation.
Even though the site is so big, space is still an issue. We can't expand indefinitely. So we decide where to put storage areas and cranes, which cranes to set up and dismantle and when, in order to avoid collisions with other cranes.
The apron control tower has now nearly reached its final height of just under 70 meters. The last floor is ready. The cantilevered control center is already taking shape at the top. This is where the apron traffic controllers will work, with slanted glass windows intended to give them an ideal view of the runway with minimal glare. The workers are currently dismantling the climbing formwork and digging out the foundation for the crane, where the base will soon be filled. Sebastian Wolber and his core team are already planning the next scaffold to be set up around the tower. The work on the facade is far from over.
We're adding a thermal insulation system, which we are applying with a finishing coat in Terminal 3's distinctive beige color, as well as an extra scaffold around the top of the control center to enable the facade work. That's definitely the trickiest part of the tower project, bringing in the large facade elements, then assembling them at an angle, and making all the necessary connections with the building.
So the team has a long way to go before Terminal 3's control tower is operable. "45 meters wide, 127 meters long, and 2,000 tons in weight, atop the assembly platform at the main terminal building lies a veritable colossus. The first roof segment has been assembled and will soon slide down the blue auxiliary construction into its final position. The Austrian Stefan Zorli has spent a whole year planning and calculating this project with his steel construction team. Now is his chance to prove that he can put it all into practice.
The challenge now was that the shell was already finished, and we had to develop and create a steel structure that can transfer these loads onto the existing shell. And then there's the fact that we're pushing a 6,000 square meter roof segment 180 meters down to the end of the hall at a height of 30 meters.
Why does it work?
Good question. Because it has to.
Going upstairs. Work with a view. The blue auxiliary construction will be completely dismantled once the roof segments have been moved. The black supports will remain as end supports for the later supportive structure. The team has installed 70 carriages to enable the huge roof to slide off the assembly platform.
The roof segment itself rests on these skidways, as you can see here. And then the roof is pulled forward using hydraulic presses and ropes.
The skidways show the way. Each of them will receive 7 steel cables, so-called strands, which will pull on the front carriage of the roof segment. The workers have to check them constantly to ensure that the segments don't tilt during shifting.
The roof structure is now being pulled to the end on these 5 skidways. The steel cables are currently attached to 3 tracks. Our colleagues are still working on the other 2. And at the end, you can see the green hydraulic presses, which pull the roof along.
The green presses, which are there to generate the necessary shifting pressure, are set up by a specialist Swiss company. Stefan Zorli can see his colleagues are already positioning themselves. All the strands are ready. The shifting is about to begin. General Project Manager Christian Behrendt wants one last pep talk. This is a special day for everyone on site.
In fact, this is the milestone which marks the end of the shell construction work in the check-in hall. And the first stake is being hammered in for the steel roof so that the interior work can begin. Really, the final step. Actually, the most decisive and the most spectacular.
Workers remove some of the carriages which were attaching the roof structure to the assembly platform. Only 25 of them are going the full distance. They're connected to each other by drawbars, so the space between them does not change. The roof is moving, very slowly. And for one moment, the Terminal 3 construction site stands still, watching and listening. 6,000 square meters of steel are on the move.
During the operation, the hydraulic cylinders always lift 30 centimeters at a time, while the supporting structure is always pushed forward the same distance. The important thing is to pull evenly, because otherwise the structure would tilt, and that would cause massive problems.
Workers on the cherry pickers accompany the operation, checking the strands at the front and the hydraulic presses at the back. They also need to be lubricated regularly. Down in the control container, a colleague keeps an eye on the pressure.
These presses are all electronically connected. That means if one of the parts is heavier or pulling harder, the pressure in the press increases to always maintain the distance of 30 centimeters.
At the rear of the presses, the strands are guided to the ground, where workers pull them back towards the starting point. The closer the roof gets, the more cable accumulates. 30, 40, 50. For nearly 50 meters, it's going according to plan. The roof segment is moving further away from the lifting platform. But then it comes to a halt for the first time. There's a problem with axis 60. It seems that several of the steel cables are too loose, and Stefan Zorli is getting tense.
It might be that at this length it was looser than when we were setting it up. And when the clamp grips it, it gives a few millimeters before gripping properly. We either need to pull it back somehow, or just apply more pressure to pull more on the track where it's jammed.
While the roof segment is paused for now, the ground crew is whirling around technical site manager Christian Nott. For 25 years, he and his team have been a kind of fire brigade for steel construction sites. They offer quick and versatile support when things get stuck, jammed, or too loose.
Our problem was that some of the cables didn't hold as they should have, so that 2 or 3 got stuck behind. And then we have something of a knot in the front, which we opened up, and now we're pulling them all back.
The workers open all of the existing connections and knots, pulling the 7 steel cables to the same tension to create an even pull at the top. Then they can reconnect the cables and cut them to length. All of this takes time. It's already the weekend, and tomorrow is Sunday, the one buffer day. On Monday morning, other crews are arriving, and Solly's 52-men-strong team has to leave the site.
That's the schedule. The clock is ticking.
The beginning is always hard on everyone. It's not something you do every day, that's for sure. And everyone has their worries. Does everything fit? What about there? We've checked over everything again, but it's all going well in all honesty. Apart from a few small problems, that's always the case.
Night is falling here at the main terminal building, and the 2,000-ton roof segment has made most of its way, despite a few interruptions. There are only a few meters left, which can easily be made up tomorrow. The workers dare to do a little dance.
The first segment was the premiere. Of course, I'm glad it's over now, and that everything went according to plan. The tension is gone, everyone's more relaxed. We're just happy that everything worked out with no accidents or complications, and that the roof is in its final position.
und das Dachtragwerk seine Endlage erreicht hat.
4 additional segments will follow over the coming months to complete the roof. That's the way it's here at the main terminal building and throughout the whole T3 site. From Piers J, G, and H, to the apron control tower and the Skyline train, Frankfurt's new terminal remains one thing above all: a mega construction site.